When faced with wall damage, deciding between repair and replacement hinges on cost effectiveness and the extent of the damage. In many cases, repairing the damaged area proves more economical than replacing the entire wall. The repair procedure typically involves several steps. Firstly, remove any existing patches, such as a plywood patch, that may have been applied to the damaged area. This allows for a clear assessment of the underlying structural damage. Secondly, thoroughly dry the affected area. Moisture can exacerbate damage and hinder the effectiveness of repairs. Ensuring the area is completely dry prevents further deterioration. Thirdly, replace the damaged studs with new touches for studs. This is a crucial step in restoring the structural integrity of the wall. Use glue and a nail gun to securely fasten the new studs in place. The glue provides additional bonding strength, while the nail gun ensures quick and efficient installation. Fourthly, reinforce the area around the repaired studs with plywood or another suitable material. This reinforcement adds extra support and stability to the repaired section of the wall. The choice of reinforcement material depends on the specific requirements of the repair and the surrounding wall structure. Seeking the advice of an engineer for this type of repair may not be necessary, especially if the damage is relatively minor and the repair follows established construction practices. However, when it comes to electrical work, safety is paramount. If there are any doubts or uncertainties regarding electrical wiring or connections, it is always advisable to call an electrical inspector for guidance. Electrical inspectors are qualified professionals who can assess the safety and compliance of electrical installations. Their expertise can help prevent potential hazards such as electrical shocks or fires. When working with Romex or any other type of electrical wiring, it is essential to adhere to all applicable electrical codes and regulations. These codes are designed to ensure the safe and reliable operation of electrical systems. Understanding and following these codes is crucial for preventing electrical accidents. If you are new to Romex or unfamiliar with electrical codes, do not hesitate to consult with an electrical inspector or a qualified electrician. They can provide valuable guidance and ensure that your electrical work is performed safely and correctly. In addition to seeking professional guidance, there are several resources available to help you learn more about electrical safety. These resources include online tutorials, educational videos, and publications from reputable organizations such as the National Electrical Code. Taking the time to educate yourself about electrical safety can help you avoid potentially dangerous situations. When performing any type of electrical work, always remember to disconnect the power supply to the circuit you are working on. This will help prevent electrical shocks. Use a voltage tester to verify that the power is off before proceeding with any repairs or modifications. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect yourself from potential hazards. Keep a fire extinguisher nearby in case of an electrical fire. Never work on electrical systems while standing in water or on a wet surface. Water is an excellent conductor of electricity, and standing in water can significantly increase the risk of electrical shock. If you encounter any damaged or frayed wires, replace them immediately. Damaged wires can pose a serious fire hazard. Use only approved electrical components and materials that are rated for the voltage and amperage of the circuit. Never overload electrical circuits. Overloading can cause the wires to overheat and potentially start a fire. Use surge protectors to protect sensitive electronic equipment from power surges. Power surges can damage electronic components and cause them to fail. Regularly inspect electrical cords and appliances for signs of wear or damage. Replace any damaged cords or appliances immediately. Keep electrical outlets and switches clean and free from dust and debris. Dust and debris could accumulate and create a fire hazard. Never run electrical cords under rugs or carpets. Cords can overheat and potentially start a fire. Avoid using extension cords as a permanent wiring solution. If you need more outlets, have a qualified electrician install additional outlets. Be aware of the location of underground utilities before digging. Contact your local utility company to have them mark the location of underground utilities. Never attempt to repair or modify electrical equipment unless you are qualified to do so. Electrical work should only be performed by qualified professionals. If you have any doubts or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide expert advice and ensure that your electrical system is safe and reliable. In addition to electrical safety, it is also important to consider the structural integrity of the repaired wall. Ensure that the repaired studs are properly aligned and securely fastened to the surrounding framing. Use appropriate fasteners and techniques to ensure strong and durable connection. If the wall is load-bearing, it is essential to consult with a structural engineer to ensure that the repairs are adequate to support the weight of the structure. A structural engineer can assess the load-bearing capacity of the wall and provide recommendations for reinforcement if necessary. When reinforcing the repaired area with plywood or another suitable material, use screws or nails to securely fasten the reinforcement material to the studs. Ensure that the fasteners are long enough to penetrate the studs adequately. Overlap the reinforcement material onto the surrounding wall structure to provide additional support and stability. If the wall is finished with drywall, apply drywall tape and joint compound to the repaired area to create a smooth and seamless surface. Sand the joint compound smooth after it has dried. Prime and paint the repaired area to match the surrounding wall. Inspect the repaired wall regularly for signs of damage or deterioration. Address any issues promptly to prevent further damage. By following these guidelines, you can effectively repair wall damage, save money, and ensure the safety of your home. Remember to prioritize safety and consult with qualified professionals when necessary. The National Electrical Code, often referred to as NEC, is a comprehensive set of standards for safe electrical installation and maintenance. It is updated every 3 years by the National Fire Protection Association, or NFPA. Understanding and adhering to the NEC is crucial for ensuring the safety and reliability of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the design, installation, and inspection of electrical systems in residential, commercial, and industrial buildings. One important aspect of the NEC is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Excessive current flow can cause wires to overheat and potentially start a fire. The NEC specifies the size and type of overcurrent protection devices that must be used for different types of circuits. Another important aspect of the NEC is grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to trip overcurrent protection devices and prevent electrical shocks. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. The NEC also includes requirements for wiring methods. Wiring methods refer to the way in which electrical wires are installed and protected. The NEC specifies the types of wiring methods that are permitted for different applications. Some common wiring methods include Romex cable, conduit, and armored cable. In addition to these general requirements, the NEC also includes specific requirements for different types of equipment. For example, there are specific requirements for the installation of lighting fixtures, receptacles, and appliances. The NEC also includes requirements for the inspection and testing of electrical systems. Regular inspections and testing can help to identify potential problems before they become serious hazards. Electrical inspectors are trained to identify and correct electrical code violations. They can also provide guidance on how to improve the safety and reliability of electrical systems. The NEC is a complex and comprehensive document. It is essential to consult with a qualified electrician or electrical inspector to ensure that your electrical system complies with the NEC. Failure to comply with the NEC can result in fines, penalties, and potential safety hazards. One example of an NEC requirement is the sizing of conductors. The NEC specifies the minimum size of conductors that must be used for different types of circuits based on the amperage rating of the circuit. For example, for a 15 amp circuit, the NEC typically requires the use of 14 gauge wire. For a 20 amp circuit, the NEC typically requires the use of 12 gauge wire. Another example of an NEC requirement is the spacing of receptacles. The NEC requires that receptacles be spaced no more than 12 feet apart along walls in habitable rooms. This ensures that occupants have convenient access to electrical power without having to use extension cords. The NEC also includes requirements for ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shocks. They are required in areas where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the current flowing through a circuit and trip the circuit if they detect a ground fault. A ground fault occurs when current flows through an unintended path, such as through a person's body. GFCIs can trip in as little as 0.3 seconds, which is fast enough to prevent serious injury. The NEC is constantly evolving to keep pace with new technologies and safety concerns. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical system is safe and compliant. You can access the latest version of the NEC from the NFPA website. You can also attend training courses and seminars on the NEC. By understanding and adhering to the NEC, you can help to prevent electrical accidents and ensure the safety of your home or business. Regarding conductor sizing, the National Electrical Code provides tables to determine the appropriate wire gauge for a given amperage. For example, NEC Table 310.15b16 outlines the ampacity of insulated conductors rated for up to 600 volts, based on insulation type and temperature rating. A common example is copper wire with THHN insulation. For a 15 amp circuit, 14 American wire gauge, or AUG, copper wire is generally sufficient, provided other conditions like ambient temperature and conductor bundling are within acceptable limits as defined by the NEC. For a 20 amp circuit, 12 AWG copper wire is typically required. It's crucial to consult the specific NEC table and consider all relevant factors when determining conductor size. This ensures the wire can safely carry the intended current without overheating, which could lead to a fire hazard.